Okay, good evening. Let's continue our class. Okay. Oops, wrong. Sorry. I need to share the screen. Entire screen. Share. Share. Okay. Oops, wrong again. This one? Okay. Okay. Yes, last week we already discussed process mining and large language model. I think we have this meeting and next week meeting with me. Next week I will talk about Python and Crash. I think many of you already know about this, so this is not a priority. Most of the stuff has been discussed, but on the other meeting I failed to show you about time series. And also, I already sent you the data from the Ministry of Cooperation and Small Medium Enterprise. Uh, I will try to see how to play with that with the data sample from the Ministry of Cooperation and Small Medium Enterprise. Okay, so I did reinstall. Finally, I have to reinstall. I did reinstall the time series plugin for Orange, so we can play around a little bit with time series. Okay, so I minimize this one. I think I can. I, okay, I can minimize this. I can go to this one. Okay. Okay, I will start Orange. Okay, I have several data on time series. This one, time series. So I have this data. Oops. Okay, Orange is running. Okay, this one is the data. One of the data. Okay. This is electric production in one of the generator, and I don't know whether this one is in kilowatt or I don't know. So this is not basically the target. This may be megawatt or kilowatt, and because this one is time series. The date is on in the first column is the date. Okay. Now the problem with Orange can only read this kind of format. So year minus month minus date, and then space, time, hour, minute, second, with space in between. So Orange can only read this kind of format. If, for example, we want to change into the other different format, we have different format number. For example, let me see if I can. Oops! Now I'm in trouble. Undo. So the other format, it can be slash, it can be we can write down the month like October, November, December, January, and whatever. So we can write down the month, or we can use this format. Unfortunately, Orange can. I think it seems Orange can only read this kind of format. Okay, so we have this data. This is the electric production, and don't save. I will be in trouble if I save it. This one is the original format. If you have the format like this, you have to convert the format into the other format. Unfortunately, I have to do it manually. So this one, I don't know how many lines. This is 100 something. It's more, I think around 300 something. So close to 400, I have to do it manually. So I did it this morning. So yes, it works, but I have to do it manually because I don't know how to do it automatically. And then this one is another format. Let me see if I can read this one. Oops, sorry. Nope. Where is it? Oh, this one. Okay. See this one? Uh, this one we cannot process. So I did try to download from, I think I download this from Kaggle or something. So I tried to download time series data from Kaggle, and then we have this kind of format. So we are in trouble. So I cannot process this kind of data. So we have, so Orange is not that smart. We have to manually, sometimes we have to manually change things manually. So it's not by Orange. We have to do it on this spreadsheet. Okay, let me see the other data. So historical is not working. This one is an example for stock price. So this one is date and hour, minutes, second, and this is the stock price. Okay, so having this kind of data, then we can use time series feature in Orange to predict. Okay, let's play around with the prediction in time series. Okay, so this one is Orange. Oops. Okay. Okay. I close all of the thing. Okay. Now, this is the time series widget. The problem with the time series widget here, there is none of this widget for reading the data from Excel. So to read the data from Excel, we need this one, this file widget. And then we have to transform the spreadsheet data into time series data. Okay, and then we have to define which one of the time series data is the target. So we have time series. We can have also feature, and then we can define a target. Okay, let me play around with it with the time series little bit. Let me do. I like to play around a little bit. So maybe later. Okay. Now, I grab the file widget and then see if I can read. Okay, I will upload the electric production comma separated value CSV file. Okay, so we have date time. So Orange recognize that the date column is date time type. Okay, we have to see this too. So all of this column is recognized as feature. I need one of the column as target, not feature. So see this? Data has no target variable. So we have to specify, we have to tell Orange which one is the target. Okay. Reload. Okay. Now, if we want to see the data, we can send it to this data table widget, so we can see this one is the date and this one is the power generated in one of the power company generator. Okay. Now our task is to predict beyond 2018. So this is 2018 January. So what happened in February, what happened in March, and so on. So we want to predict the value of the power generated in 2018 February, March, April, and so on. Okay. Now, we need to transform the data first. We need to select the column. Okay. As we oops. Okay. I already defined. Originally is the format is like this. So both column, both date and the power, both is feature. So I have to move here and move here. Okay, so we need to have at least one target and one feature. The feature we use here is the date, and the target is the power. Okay, but our format is still table, so we need to convert the table into time series. Okay, so we need to send it to time series. We have to tell Orange which column is the date, the time. So select column with date. So we have two column, date and IPG 2211A2N, I don't know, whatever. This is the name of the generator, and we select date as the date. Okay. Or we can specify if we actually measuring IoT, we do some IoT, and we can specify the sequence of the instance. It can be one. Normally it's not 1 second, so it can be 20 second or whatever. So we can change this one. Okay. If we use this one, then the sequence is we don't need the date and time. It based on sequence. Okay, but in our case, we already specify the date, so we select this one. So okay, so this is the time series. Let's see how the data looks like. This is so we send the time series to line chart for time series. See this? We have time series and we have forecast. Okay, so this is the actual time series, the power generation. So basically we need to predict the power generated here. Okay, let me see if I can I do some sliding window. No, I cannot do some sliding window here. So okay, so there is no prediction yet. Okay, now to do some prediction, we need to feed the time series data to one of this model. I normally use ARIMA model for time series prediction. Okay, so I can feed the time series data to ARIMA model. It will okay. Oh, email. So we can play around with the parameter. It has auto-regression order, differencing degree, moving average order, and forecasting step ahead. So how many, in my case, the forecasting, if it is 20, that means I don't know, 20 something, 20 month. Or let me forecast for only a couple of months. Okay. Nope. I think I'm in trouble. I crashed everything. I have to do it again. Sorry, we have to do it again. Seems change restore now. Restore now. Okay. So I only predict two step ahead. Okay. Now we have the original time series. Okay. Now if we want to check for the value of the forecast time series, we can fit the output of ARIMA model to line chart. Okay. So the forecast goes from ARIMA model to line chart. Okay, not the time series. So I fit this way, then here this actually the forecast value. It's not clearly, we cannot really see because we have so many years behind, but we can play around with this one. So we can moving average, we can reduce, we can increase, but it's not really clear here. Okay, let me change the data. So basically, this one, the dashed line is the forecasted value. Okay, let me change the data now. Okay, I close this one. Okay, let me change the data. I change the data to time series stock. Okay, so I have date time and the stock is numerical value. The file is something like this. So the data is every hour. This is midnight. 1 hour, 1 o'clock in the morning, 2 o'clock in the morning, 3, 4, 5, 6, and so on up to 1 o'clock. Sorry, midnight that day. Okay, and then we have the value of the stock. Okay, so having that, we can select the stock as the target. Time is the feature, and then we can fit the time series to this line chart. So we can set this kind of value. Okay, now as you can see, we can see slightly here about the prediction. Now I will increase the prediction to 20. See, hopefully it will. See, it's 20 hours from basically 20 steps. Okay, now we can change the confidence interval. See, if I reduce the confidence interval to lower value, this thing will see the spread will be much narrower. Okay, so we can change around the spread by changing the confidence interval. Okay, let me see if I think we can wait little. Let me see if I use 10 steps. What happened? Hopefully it will pass much faster because 20 is too far away. Okay, let me increase the confidence interval so we can see the spread is increased. Oops, wait. Wow, takes some times. Otherwise it's difficult. Come on. Wow. Okay. See, it's increased. When I increase the confidence interval, the spread will be increased. We can play around with this one. For example, if the moving average increase, what happened to this one? See, I increased to so slow, eh? See, it. Let me use 10. Oops, going up too high. So the moving average, I said, wow, okay. So 3, and we can also play around with this. We can play, oh, see, it's going down. Or we can increase this one. See this? Or we can play with this thing, auto regression. So we can play around with these variables. Oops, too much. Okay. So basically, we need to change our variable, and we see the graph. If the graph is suitable for us, then we can save the graph, basically. So it's not an what's that? An exact value is a probability. It's sort of the in the future the value is within these boundaries, and that's how we say it during presentation. So based on our algorithms, so the value might be around these boundaries. That's it. That's how we play around with time series prediction. Okay, I give you some example for time series prediction. But this one is my example is not using. Let me see if I can. Okay. Bitcoin or Indodex. Let me log into Indodex. Let me see if I can log into Indodex. Login. I think I need to. This is my email. The protection is quite high. I hope it works. Okay, it will send email to me. Let me, okay. Confirmation. Yes, it's me. So I can log into Indodex. So basic. Oh, I have to tell you guys. I was a miner. So I was a miner in the past. Yes, I did mining. Yes, I did trade some Bitcoin in the past. I think I still have some mining USB miner somewhere. I don't know. I put it somewhere. So yes, I did some mining, and I did trade. To be honest, I am having difficulty when I have to do mining because my gadget is not strong enough, so I not get any money basically. So yes, but I did get some money when I do some trading. So this is for trading. So basically, same thing basically. Play with stock market, play in stock market, play in foreign exchange, play in whatever. It's a time series problem. Okay. Let me see. But this one is not. So we are not using time series basically. I will show you a little bit how to do trading in Bitcoin. I have to store the money for how many years? 2 years basically. So yes, I did store my money for 2 years. So this is the my remaining money. I take out all the money, I think, last year. So this is actually only the remaining money. So this is the stock Bitcoin price in Indodex. Okay. And then when we want to decide to buy or to sell, we need to see this price. Basically, the logic is if the price is at the peak, then we sell. If the price at the bottom, then we buy. But this one is not necessarily the bottom. This is more lower than this bottom. Okay, so but we don't know yet which one is which. So to do those things, I normally, let me see if I know how to do this thing again. Uh, where is it? So okay. Oops. Nope. Not this one. Bitcoin. There is a feature within Index that we can analyze these things. Let me see if I can find these features. I forgot where they put it. It's built in the Index. Wow, so low, so slow. Uh, okay, nope. See, the latest price for one Bitcoin is close to 1 billion rupiah. It's nearly uh, is. Let me see if I can find the module. Wow, so slow. We can shift the analysis to like uh, 1 minute, 5 minute, 15 minutes, every hour, every 4 hour. This is the sequence. So this one is every 4 hours. So this is the price every 4 hours, and then this is the date. So basically, the Bitcoin price is basically increasing, but can I be more analytics? Let me see if I can do more analytics here. Oops, no, not this one. Uh, where is it? Where is it? Auto fit, lock, sell, invert, time zone. Nope, not this one. I cannot find competition. I'm looking for the feature to analyze this data, but it's not this one. No, not this one. Sorry, I forgot where they put it. So what I need is the trading. Oh, okay. I never use it. So let me see. Trading view. Let me see if I can see in trading view. I used to check on Bitcoin charts, but the website is down. Where is Bitcoin? Here. This one? This one? Okay, let me see if I can log in. Nope. Okay. Oops. Whoop. I need to log in. Yeah, okay, okay. Next. Let me see. Get started for free. BTC. Okay, launch the chart. Let me see. Okay, and then I need, okay, indicator matrix. Let me see if this is the, okay, this one. This is what I need. Where is the moving average? Moving average. Simple, for example. So we can average, it can calculate the moving average. So basically, this is the moving average. The blue line is the moving average. So basically, we can see here. So this is going down and this is going up. So and then basically normally we can adjust how many days it will calculate the moving average. Okay, so basically we can see the trend from the moving average. What I normally do to decide whether I will buy or sell, I think I did sell my Bitcoin around here or here. I forgot. Or here. No, no, not here. Here, I think. This is when I sell my Bitcoin. So, well, I get like 100%. So I double my Bitcoin at that time. But I'm not putting a lot of money, so I'm not getting so much. So to decide when to sell, buy and sell, I normally use this one. Where is it? This one, RSI. Where is R? Yeah, this one, Relative Strength Index. This is what I normally use basically. Okay. Okay, I close this one. Okay, here is the. Okay, how can I? Oops, sorry. I want to see this chart at the bottom. How can I? So okay, okay. So I normally use this chart RSI. If so, we have two. What's that? Lines here. This is 30%, this is 70%. If the graph is above 70%, that means it's time to sell. If the graph below 30%, it's time to buy. So this is when to buy. There is like not many times we can buy Bitcoin basically. So when at that time I put my money for 2 years and I get 100% return. So basically the interest is 100% for 2 years. It's like 50% per year. It's okay lah. Okay. So I monitor this one. So it's nothing to do with this orange. So I'm not using this one. So I should be using this one in reality, the RSI. So I just want to show you how we play around trading the trading Bitcoin, trading foreign exchange, trading stock. Yes, sometimes we can use time series, but sometimes we can use this one. Okay, I'm not using this one actually, not using time series. I normally use this one. Basically, I need to decide when to sell, when to buy. That's it. I don't really interested to see if it's going up or down. I'm interested to know whether it is the lowest or it is the highest point. That's it. So that's time series. Okay. Let me check if you guys have any questions. Uh, oh, okay. It can transcribe. Okay, good. Okay, let's move on. So that's time series. Uh, so I will close time series here. Let me see here. Now, I think the other day, 2 days ago or 3 days ago, I sent you guys an email. In the email, I send you the data from the Ministry of Kooperasi and Small Medium Enterprise. This is only sample data, so it has only how many data? 900, 1,000 small medium enterprise. Basically, it's not small enterprise. This is micro enterprise. So this is not small medium enterprise. This is micro enterprise. See the scale of the is micro. In all of them, 1,000 micro enterprise. So there is nothing to do with the scale of the business. But basically, it has how many? A, B, C, D, in only few. U, A, B, C, D. About 20. So we have about 20 feature in the data. The actual features of the data is close to 200 feature, but they will not give me all the feature because some of the feature has private data, so they don't want to breach the law. So they only send me like 20 feature and only 1,000 data. The actual data is more than 13 million data, and all the number of feature close to 200 feature. So they have lots of data. The problem with the ministry, they don't know how to analyze the data basically. So they asked me to teach them how to analyze this data. And I asked them if 2 or 3 of my students can join during the training session. They have not decided the training session when the training session is, but they are welcome 2 or 3 people to join in. If you like to join, you are welcome to let me know. I think one of you already sent me email that he or she is interested to join the training. Okay, but I'm expect you not to be the student during the training session. I expect you to become my assistant basically, because the ministry they don't have the capacity to analyze. You guys already received my lecture for several times, so you know how to do these things. Let's play around with this data, see what happened. Okay. So the data name is UMKM sample Bekasi City. Okay, let me see if I can read the data. Okay, so I remove all of this, and then I will read the this one. Okay, so we have around 21 feature. See 21 feature. When we see this, we have 1,000 instance, 21 feature, no target data variable. That's interesting. So we don't have target yet. Okay. For the ministry, I think the target is to classify basically, to classify what kind of business this for its instance. Unfortunately, all of them are micro, so there is no sense to classify for type of business. Okay, so type of business is out of questions because all of them are micro business. Okay, so we don't have to reclassify again. When I ask them how do they classify the micro business, it's based on regulation. That's it. So it's not based on algorithm, it's based on regulation. That's how they classify the business. Okay. Well, okay. Let's play around with this then. Okay. So yes, we can read the data. If we want to see the data, this is the data. Okay. So this is the data. Now, number not make sense. province, not because all of them is from Jawa Barat. Kabupaten not make sense, kecamatan not make sense, kelurahan not make sense. Yes, sometimes it makes sense, but mostly. Now we are having this one, the modal pendirian, the money we put when we set up the business, will be interesting to see. This one not make sense. This is the month when they start the operation of the business. This is the year, not make sense. This is the gender, disability. I think we have only one defable. I think only one. Yeah, this one. There is none. There is no other defable. And this is the status. This is the level of education. Okay, let's play around a little bit. Okay, see when I fit the data here. Okay, the one that not make sense, I put it into ignore. Okay, originally is like this. See, this is all the features, and then I like to play around with OMSET, the income they can generate from their business. That would be interesting to see. And then I like to see also the correlation between income or OMSET with the investment. Okay, the investment is which one? Modal pendirian is the investment. Okay, so I want to see the correlation between OMSET, investment, OMSET, and maybe category KBLE is, I think, type of business. See that's the KBLE. It has 11 values: service, health. So we can see the type of business here. Okay, now uh, when we analyze this data, first I want to see which feature will contribute most to the target. So because we have 14 features, and then we have to check which one is the most influential, give influence to the target. To check that, I normally send it to rank here. So from select column I send it to rank. So it will work for a while. Okay, now I can see. This univariate regression there is not available, so I can remove this. So I only have one, and then I set for 6 best rank. So I have to rank this one first, and then I select 6 best rank. This is 1, 2, 3, 4, 5, 6. So this 6 feature is actually will define the OMSET. Okay, so basically OMSET will be defined by type of business, level of education, whether they have what is laporan keuangan, ledger. This doesn't make sense when the month they start operation. This one doesn't make sense. So actually this can be removed from the list here. This one we can remove from the list because this doesn't make sense. Where is the others? Okay, I think all of the other are makes sense. Okay. Okay. How about 6? So wow. Now it's different. Okay, let me make 7. So method for marketing, ledger, type of business, do they have any business number or are they registered? How many male worker, how many female worker, and the 7th is the education of the owner. the level of education. So this is interesting. So when I remove the month, then method for marketing is number one, because this is interesting. I thought this one is number one, so it's not. It's this one. Okay, so it's changed significantly. Okay, now having said that, let me see how it looks like when we measure the. This is basically when we see the data. Okay, see there is no target, and we define the target. Yes, we can play around as supervised learning, but in our case, I want to see if the OMSET can be classified to several cluster. So having said that, we need to see the clustering of the data. That means I want to see unsupervised learning of this data. Uh, so to create unsupervised plot, I send the column to distance with OMSET as target. Okay, and then see how the cluster looks like. So this is the cluster looks like. Let me see if I can use OMSET. Okay, this is the income. The income. Okay, this is the cluster look like. I create 5 clusters. Of course, we can increase if you like. 6, 7 cluster, 8 cluster, 9 cluster, whatever. So if you set up many cluster, it's more difficult to analyze. So I normally reduce into like 4 or 5 clusters, maybe 4 clusters. Okay, 4 clusters is interesting. So if we see the cluster of the income, see the pattern. How many zeros here? Okay, so this is interesting. This is basically the average business. This is, I don't know, maybe it's not average, and this one is not average. Okay, but the income is sort of the same here, and here are the same. But this is not average business. This one is not average business. Okay, but the income here is very big here, but this one is also quite high, but this one is phenomenal. Okay, this is quite high. This is another group here, but the income is not that different. Okay, but this one is quite different. Okay, let me see what makes this difference. Okay, right now the annotation is OMSET. If I change the annotation into what, level of education, now we can see the difference. Okay, let me go back to OMSET. OMSET. See, this one have lot of money. This one so-so. This one is average. This one is low. This one is average, but this one is quite high. What make the difference here? Let's see the level of education. See this? We have university and high school graduate, and university bachelor. This one is junior high school. This one is university. So this one basically junior high school. This one university. This one also university bachelor. What make the difference between this bachelor and this bachelor? Okay, let me see what else. This one, investment. When we see the investment, see this, and this one, same. So the section, the high school, actually use the same investment. Let me see the level of education. See, this is junior high school, and this is master degree, and this is bachelor. They use they separate the cluster into different cluster. But actually, when we see the investment, same investment, same investment. This one, it's much lower investment than the other two. This this part is much lower investment than this one and this one, but when we see the income, it's quite high. This one has same investment as this one, but the income is lower. So uh, some of the result from our analysis that if you give a lot of money but the education is not that high, it will not generate that much income. That's one of the conclusion. Maybe wrong, but from the what we see, this part, most of the education is junior high school. Even the investment here and the top upper and the bottom lower, same investment, but the bottom lower they have much higher education level. It will generate much higher income than the upper lower, the upper end. And in the middle, seems the investment are the same. Let me see the investment. It's about same. It's not that high. It's average except these two, very low, only 500,000 rupiah, which is low. This part and this part, it has high school, university level. Let me see. Wait, sorry. Education. See this? It's university level. So if we give university level person same money as the high school person, it will generate more money. Seems like that. Okay. Now let me see the type of marketing. Type of marketing they are using. Most of them are non-digital. Only this one digital, and this area mostly digital. This one is non-digital, but this one it has a lot of money. Uh, the education level is high, so those with a lot of money, high education, they tend not to use digital like e-commerce. Like this one, this part it has average investment, but a lot the education level is higher. They tend to use e-commerce and they tend to get a lot of money, more money than the others. See, so it seems like if we have higher education, if we have normal investment, then digital marketing, e-commerce will significantly help that kind of person, and they will get a lot of money out of the investment. So we can play around with the analysis like that. So if you do the analysis, you can find something like this. So we can, if we see the actual data, it will not tell you anything basically. Here, see if we see the data, that's it. No conclusion from the data. It's more difficult to see the conclusion from this kind of data. So we need to analyze using that kind of thing. And then the most interesting thing, because I will likely to be able to access the 13 million data from mostly micro. They said to me most of the data is from micro business. So I don't know, maybe we can see from different area, maybe different characteristics. It will be fun to see these things. Of course, we can also split the classification into type of business and so on. So if we want to change the analysis, we can do something like this. So this is one analysis. We can always change the column. For example, we like to see what category of business. Okay, what will influence, what kind of feature will influence each type of business. Okay, then we can see here. Whoops, interesting. See the scoring method. A lot of scoring method now we can use. So the type of business, the first one is OnnoCenter. If they have ledger, investment, if they use technology, but this is depends on. Oh, I have to sort first. Maybe if I use this one, we have different rank. If I use Genie, we have different rank. If but most of them will be OnnoCenter is number one. Okay, okay. This one is if they have ledger. This one is the investment and so on. So depending on type of scoring method we are using, it will show different results. Oh, okay. So if you use this one, OnnoCenter is number 3. Level education is number 1. Interesting. Okay. See this? So this one is for type of business. Let me see what kind of type of business. Okay, now this is the type of business. Let me see if I can split into what 7 type of business. So most of this area is big business. This one is hotel. This one is service. This one is industry. This one is big business. So okay, so this one. And then how about the investment or investment? Oh, the investment is same, eh? Same type of. Oh, but this one is different. But the two far end, the high end and low end, same. Let me see if the education is same. Okay, this is the junior high school. This is the okay, same, except this one. This this one, it has no never finished what primary school. This one finished primary school, but so this one is shifted a little bit. This section is shifted a little bit, but the rest very similar basically. So the cluster of what is this? The type of business similar to OnnoCenter and so the cluster is like this. Okay, interesting. So I'm still playing around with this. So basically, you are welcome to play around with the data. If the Ministry of Koperasi and micro and medium enterprise have set the date, I will let you know. So those who want to join, feel free, but it will be limited to 2 or 3% only, basically. So let me know if you like to join, but it will be limited to 2 or 3%. Okay, so that's it. Okay, let me see if there is any questions. Pak Fatur interested? Okay, when the event? I don't know yet. They have not decided yet. Where, when? We don't know. But yes, I already sent the what's that, the training materials, basically our class, to the minister. So basically the same material, but from Orange point of view, same Orange. The difference is we will focus on analyzing the data. So we are not play around with many different data. Basically, we analyze the data from the ministry. It will be interested if you can what that make friend with them. Hopefully, you can access their data. Having access their data, then you are welcome to use the data for your thesis or your journal paper, basically. Okay, but of course, you need to be friend with them first. Okay, next. What time is it now? Okay, I have about 1 hour from now. Let me play around a little bit. Okay, so I finished with this. Let me play around with, I don't know. Uh, I like to play around with time series. See this time series? This one. Let me see if I can use more than one feature. So right now we have date as feature, and we have stock as target. Say we have other things, for example, uh, what interest rate from the bank, maybe. So maybe we have 10% interest, we have 10 here, we have 10. Wow, this is not make sense because this is only 1 hour sequence. If we have interest, bank interest, we need to have longer than 1 hour sequence. But this is only example, right? So I don't know. Maybe the interest will change between 1 hour. We don't know. So this is only example. So 10, 12, 20, 20, 20, 10, 20. Sorry, 30. Oops. To okay. This is only an example. For example, we have this kind of feature. Okay, additional feature. I don't know what feature it is, but basically we have additional feature here. I will save this one first. Okay, let me play around again with time series. See what happens if we have more than one feature. One feature is the date, time and date, and the target is the this one. The what's that? The stock price, and then we have interest rate of the bank. So let me read again. So I remove this one. I will read data, time series stock, Excel. So you can build your own file to play around with this. See, we have three features because time is not set as target. Oh, sorry, stock is not set as target yet. So basically, we have three features, no target variable available. So then we need to specify, select column, specify which one is the target, basically. Okay, stock will be a target. Feature number one we can ignore first. Okay, see if we ignore what happened to the our prediction, and then we need to transform the file into time series. So we select the column, the date is within the variable time here. Okay. Okay. Now, So we have this, and then we can plot time series here, and then we have here. Okay, this is the stock price. Now, if we want to predict, I use this one, and then fit the time series to ARIMA model, and then we can merge the forecast and the actual data to see. See this? This is the forecast data. This is the actual data. So the forecast is dashed line. The actual data is solid line. And this is the area where the most probable value of our prediction. Okay. See this what's that? The line is like that. If we add, oops, sorry. Okay, this is the line. Okay. For example, I want to include our feature into the interest rate. If we include in the feature, what happened to the prediction of the stock data? So I can include here. Nope, nothing happened. Nothing, eh? No, nothing happened to the stock data. Interesting. So, nothing. Let me change the value. Okay, for example, it's going down again. Okay, save. I have to reload. Reload. See what happened now. Nope. Oops. Okay. Nope. Nothing. Okay. Oh, so my experiment is failed. I like to see something here, but it doesn't show anything. There is no difference. Okay. So basically, we have to play around something like that. Hopefully, we can see something, or I move it into algorithmic axis. Not much different. Okay, this is algorithmic axis. Not much different. See what happened. No, it's not. Hey, really? Let me see. Oh, this is the correct algorithmic axis. Okay, no, no difference. Okay, so, huh? Is it? This is like linear axis, but I click logarithmic here. Okay, something strange. No, doesn't change. Oops. Okay, I have no idea what happened here, but seems like it's not changing. Basically, I like to see what happened if I add something here, but it's not happening. Okay. Okay. So you are welcome to play around with this one. Uh, Let me see if I can have other thing. How many hours? Okay, I have 30 minutes more. Okay, uh, let me see if I can generate something. Uh, Different data. Okay, See, say I have something data like this, 7, 8, 9, 10, and then I have the data like this. Uh, and then let's say I have like 4 column, something like that. Uh, 3, 4, 5, 7, 8, 9. So to play with this, you can make or create your own data, and you can play around with your data, something like this. Uh, okay, so suppose we have this kind of data. Okay, I want to predict. I want to predict. This is like we can imagine this as three axis, x, y, z data. So this is the actual x, this is y, and this is the value of c. If you want to plot it, we can plot something like this. View. How can I plot this one? I forgot to plot. Plot the data. Insert text box chart. Okay. Insert chart. Okay. And then, for example, I want to make 3D look. Maybe I can have something like this. Okay. Okay. Finish. See, we have three-dimensional. Can I shift it the data a little bit? No. Okay. I can make it more. Change the data. Okay. See, we have three-dimensional graphics like that. And then our task is so this is three-dimensional. How can we analyze, or how can we predict the value of a point somewhere here, or somewhere here, somewhere here, in three-dimensional data like this? Okay. So this is an example. How can we do things? To be honest, most of the algorithm for data mining, data science for Orange, we have to convert the data into X and Y. X can be many features, but Y only one. Okay, so this value is Y basically. All this value is Y. This one can be X1. This one, ABC, can be X2, basically. Okay? So we have, if we see the data like three-dimensional like this, that means we need to convert the, we need to visualize the data in our mind, okay, in 3 dimension. like this. And then we need to imagine that the algorithm need to estimate, need to forecast, need to predict the value somewhere between this range from 1 to 10 and from A to D. Okay. But I will change A to D, A, B, C, D into 1, 2, 3, 4, 4. Yeah, 1, 2, 3, 4. Okay. So this one, A, B, C, D, I will change it to 1, 2, 3, 4. Okay. So basically we have three-dimensional coordinate. This one X, this one Y, this one Z. So we can, if we map into linear equation, this one can be x1, this one x2, this one y. Okay, so we need to convert the data into linear coordinate. That means I have to change the data like this, copy. So I need to regenerate another spreadsheet. So this is the y, and then it's sorry. So sometimes you of course you can do it using program, but sometimes I do it manually by hand to get some feeling too. So this one is 1, 2, 3, 4, 5, 10, and this one 1. Suppose A is 1, so that means I have, but we have to be consistent. For example, this one is 1, 2, 3. Is it same? Let me see. 1, 2, 3, 4, 5. Oh yeah, okay. Okay. So this one 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But this one is 1. So this one is x1. This one is, or I can insert. This one is y. This one is x1. It's sorry, x1. This one is x2. So this one is more readable for the algorithm. If we analyze directly like this one is not readable by the algorithm. Okay, we need to shift first to be able to, for algorithm to read much more easier. So let me copy this one. Okay, this one, paste. Okay, again 1, 2. Better copy, paste, and this one is 2. It's sorry. Okay, now I have to copy again this one. So when you see a data, many times we need to convert the data into something that the algorithm much more easier to process. Many data heavy is set for human to process, which is much smarter than algorithm. The problem, we are dealing with algorithm, so we need to change the data first to make the algorithm. Oops. Oh yeah, same, but this one is 3. Okay, and then this one. Let me see. Okay, and then I copy this one, and then this one is 4. Okay, Now we have a data like this. So basically we have x1 and x2, and we have y. This one is the target. This one x1, x2 is feature. So basically if we see the actual data, this one is x1, and A, B, C, D is x2, and this one, the area here, oops, edit, undo, move. Okay. This area here is actually the feature, the target value. Now, our task is to create a model, so we will be able to predict what is the value in this section. This one may be like 4, and x1 is 4, x2 is like what? 1, 2, 3, 4, say 3.5. So we can have something like that. Okay. Let me see if I can. I will save this one. Save as. 3D 3D model. Okay, and then I will have this one save as 3D converted to linear. Okay, but because Orange cannot read open document file, I need to save it as Excel. Okay, so I will save it as Excel. Oh yeah, by the way, I'm using Linux, so most of the time the format is open document file. So I save it as Excel. So we have this one. Okay, let us see if we can do something with this thing. Okay, I will read the data. Now Orange 3D converted to linear data. So this one. So we have Y, X1 and X2. We have 40 instance, 3 feature, no target. So we need to change a little bit the column. So now we have, okay, it decide Y is the target. Okay, it's very similar to my thought. So Y will be target. X1, X2 is a feature. Now we need to, the step is we need to analyze the error. We need to evaluate the error for different algorithm. Oops. Okay. So we send the output of select column to test and score, and then we need to check for different algorithm. This one is linear regression. It's not a logistic regression. It can be tree, it can be random forest, it can be gradient boosting or whatever. We can play around with this thing. See what happened here. Linear regression. Okay. So if we see this, the minimum error is gradient boosting. This one is the minimum error. Okay. Random forest is close to gradient boosting. If we change the parameter here, let me see if I can change the parameter. Okay. If we can change the parameter, say we increase the number of trees to 15. See if, nope. Okay. If I reduce again, okay. see random forest is much better now. So we need to play around with the parameter and then the properties of the algorithm. Then we can see the error is can be reduced actually. Okay, but let me see if I can if I reduce the number of trees. Oh, okay, it's higher. Okay, this one. Okay, that's it. So we will select the random forest. If you want to play around, we can of course change this one as well, and then we can competing among algorithm which one is the best. From Python point of view, is actually this is actually calling different subroutine. That's it. From Python, our point of view, if we use Python, then basically what we do is calling different algorithm. Okay. Okay. So say we decide to use random forest. Okay. Oops. 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 Okay. Remove this one. Okay. Remove this one. Okay. So now we have file, select column, and fit it into random forest. Then we have model here. The output of random forest actually the actual model. Now, if we want to predict, okay, let me see if I can say we want to predict something. Okay. So, okay. Say we want to predict the value here. Okay. I will create new file. Okay. Okay. So I need to create insert row above. Sorry, this is Y. This is X1. This one is X2. Say I want to predict the value here, which is X1 is 1, X2 is 1.5. Okay. Now, I expect the value is 1.5 here because it's around here. This is 1, 2, 3. So here I'm guessing it's between 1.5. This is my guess. So then we will check with the prediction of the algorithm, how much the error we will get. Now I like to guess something here. Okay, so x1 is 2, x2 is 1, 2, 3, 3.5, for example. So I'm guessing the y is what, 10, maybe 10. Okay. Say I want to guess something here. So this one is so I'm guessing around here, 10. This one is 2.5. So around here, I'm guessing the value is around 12 or 14. Okay. So I will guess this three value. So I already put the y here as my guess. So I will save the file into 3D guessing. Okay, let me see if I can guess something here. Where is X? Okay. 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 Now, let's see if we can do some prediction. So I put prediction here. I will inject the model from random forest as a for as a predictors to the prediction, and then I need to read file again, but different file now. I will need to read guessing. Okay. I need to select column again. Okay, so the feature is x1 and x2, and the target is y. Let us see if it can predict correctly. See this? For x1, x2 1.5, I'm guessing 1.5. Random forest prediction is 2. Close enough. This is 10. Random forest guess is 4. It's quite far. The error is -6. For this point, I'm guessing 14. Random forest think 15. So only one. It's okay. So that's how it works actually. So starting from this 3D plots, where is it? This one. So if we have data like this, and then when I see data, sometimes we have to think, we have to visualize the data, what kind of data we are looking at. Sometimes this one is not the actual feature, so this is actually the target. So sometimes we need to deal with this kind of data. So we have a three-dimensional target, and then because the target is three-dimension, the algorithm will not be able to predict. So we need to convert the data to be two-dimension, something like that. Then the algorithm can predict. Okay. So if we see data, then we need to change around the data to make the data readable by the algorithm, and that's happened a lot. Don't worry. Okay, let me see if I can. This is one example. See this? This one, historical data. See? This is one example. It's good for human to read, but it's not good for algorithm to read. So if we download the data, then many times, I think many times we have to do some conversion. Sometimes the conversion process can be done automatically. Many times the conversion process cannot be done automatically, so we have to do the conversion process manually. And that's what happened with me this morning. I have to do the conversion process manually. It takes about like 30 minutes or something. To run the program is like only like less than 1 minute, but to do the conversion takes longer time. So data preparation takes much longer time than the actual running of the program. Okay, so you have to be prepared for that. You are dealing with data preparation. This is what happened with me when I did the analysis for Satu Indonesia Award. The data is like 11 years of data. They have to do the preparation for 6 months. I ran the program for like minutes, like 5 minutes. I do the coding using Orange like 30 minutes, 5 minutes running, prepare data preparation 6 months. So you can see that kind of work. The data preparation will consume a lot of time, a lot of thinking, because that's actually the actual work is in data preparation, not the actual running. Running is quick. Data preparation is, especially if we have very huge, very big data. For example, the Ministry of Koperasi and Small Medium Enterprise, they have 13 million data with close to 200 feature each. You cannot run a normal machine. You have to split the data to make a smaller data to do the analyze separately for in smaller batch. Okay, so we have to do those things. Okay, we have to think because our machine is limited, so we cannot do everything at once. Okay, so that's for you to keep in mind. Okay, any questions? Let me see. Okay, this is from Pak Azam Abizar. Is it any scenario? Is it any scenario if annotation is still not mentioned in the feature we are using? For example, we are about to seek the probability of fraud of insurance from data set. As we know, fraud is not being mentioned in the feature. Oh, okay. Before I answer for Azam Abizar, there is a question from Ahmed. I cannot see time series category in orange. Okay. If you so I will answer Ahmed first. If you install orange, okay, I close this one. Where is it? Where is my orange? Okay. Okay. If you install orange, by default, you will only receive data, transform, visualize, model, evaluate, unsupervised. That's it. So 1, 2, 3, 4, 5, 6. Okay. The rest, image analytics, time text mining, network taxable, time series, we need to install from option. So you have to click option, add-ons. Okay. And it will read any add-ons it can access. Just click the add-ons here. Networks, text, taxable, time series. Then you will have time series. Of course, you can play around with other option if you like, but be careful. Uh, One option can conflict with other options. So be careful for conflict. If there is conflict, you need to reinstall. You need to. So I did reinstall time series because last week I think I failed when I ran time series. I uninstall and reinstall again, and it works. So we have to do something like that. So yes, you have a lot of option like this, and then there is a word happiness here. Yeah? Okay, interesting. And then this is the geo. You can geolocate certain information. So, for example, in Twitter, sometimes in Twitter we have geolocation information, the GPS coordinate of the person who tweet. Having that coordinate, then we can use geo to geolocate the location. Okay, it's fun. This one is fun. Okay. Okay, so just click time series. Hopefully it works. Hopefully you will have these things. Okay. Now back to these questions. So we are about to seek the probability of fraud of insurance from dataset where, as we know, fraud is not being mentioned in the feature. Okay. Fraud is okay. Let me explain like this. Sometimes data, there is things that what not built in, that labeled by human, and there is something that not original. What is the right words? Not original. The other word is not built in, not original. It's it's just part of, for example, like this. uh, we as human, we have hand, we have hair, we have eye. That's feature. That's the not bionic. What is the correct word? I'm still looking for the correct word. Basically, there is things that's it's built in into human, and then sometimes we put label to human. For example, this guy is smart. That's label. Okay. This guy is bad. That's label. So there is label. There is things that built in or original within the instance, the actual data. Okay. So fraud is not original, is not of the data. So for example, I will let me show you example of fraud. Okay, for example, we have time series data. Okay, let me read the data again. Time series, this one. Okay, we have time series data like this. Okay, for example, we have transaction data, because fraud is happening during transaction from one account to another account. Okay, for example, this is the source. This is source, the name of the person. Okay, so we have source. I will remove this one. So basically, we have source, we have destination. The normal, this is what happened in Bank Indonesia, or the authority for handling the transaction. I think it's OJK. So this body, they will monitoring something is out, it's not normal. For example, this is considered normal. This transaction is considered normal. For example, sometimes we have something different. For example, in this one, we have 10,000 like this, and we have another 10,000. Then this becoming a suspicious. Okay, so basically fraud. This is what they tell me. So I get the story from these guys, from Bank Indonesia, from this is how they monitoring fraud. Okay, so fraud, when it happens, many times it's not normal like this. So it normally is this number like 2,000 something, and sometimes fraud is it's different. Okay, it's in statistics, it's called outliers. Okay, so it's not the average transaction. So this is, we can label this is as fraud. 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 Okay, the rest is normal. This one is normal. Okay, and this one also normal. So fraud normal is labeled by human. Okay, now having the model labeled, this is what happened with the this is what happened, I think, in July, last June or July, I forgot. So last June and July, Bank Indonesia, they set up a hackathon on AI. So Bank Indonesia set up a hackathon on AI for anything about banking transaction, whatever. So they have many of them actually building a model for detecting fraud. So this is what they are doing basically. In reality, they are not. Of course, the transaction is time series data. The transaction in the bank is actually time series. The problem with time series, we are having difficulty to track if it is the actual time series. So what they normally do, they will snapshot a certain time. For example, we snapshot, for example, how many hours? 128 to 42. How many hours is this? Uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 hours. Okay. So they will analyze based on 15 hours. But in the bank, normally they will analyze in my case is 15 hours, but in the bank they analyze like 10 minutes or every 10 or 15 minutes. So they make a snapshot of the transaction data every 10 or 15 minutes, and they analyze the transaction within that snapshot. So it is a time series data, but then they change the time series into uh, unsupervised learning by snapshot the time series. If it is time series, it's more difficult to analyze. So they change the time series into what's that? Learn supervised or unsupervised learning. That's make it easier to analyze. Okay, so that's how we play around with the data. So we are not analyzing. So time series is more difficult to analyze, to be honest. Time series is more difficult, so we have to change time series into other format, so make us easier to analyze. The easiest one is supervised learning or unsupervised. In our case, because we don't have this column, normal and fraud, we have this data only, but we have the model with label, and then this will be compared with our model, and we can detect, okay, these two fraud, having find the fraud, and then we can check the actual sender or receiver account, and then we can identify the police or whatever. Okay, so that's with fraud. Okay, I hope that answer. Okay, I hope that's answer Pak Azam Abizar questions. Okay. Okay. Any more questions? Feel free to ask. I have like what, 13 minutes. Okay. Now, what else? Let me see. There is a lot fun. There's a lot of fun things with Orange. Let me see if I can do something. Okay, let me see. Dataset. Okay. So next week we will play around with Python, but I think you already received a lot of things about Python from other classes. So okay, let me see with different dataset. Okay, for example, e-commerce. I think already did I did I where is the e-commerce? I forgot whether I already uh, market basket, Titanic, wine, zoo. Okay, I cannot find. No, not this one. Cybersecurity breach. No. Okay, no, 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 no. Okay. Oh, this one. Online retail. Oops, sorry. Okay. So I download the online retail data. The data is looks like something like this. Okay, so this is the data. So we can analyze based on, so we can define, there is no target variable defined yet, but we are welcome to set any variable as target, or we can cluster based on feature, like based on the feature. Okay, the problem is this line is basically the invoice. Invoice number, we have invoice date, we have countries, and this is the thing that people buy. Okay, now if we want to analyze, we can make a cluster by, I normally what I do is transpose the matrix. So we can transpose the matrix, and then we can see the matrix look like. So we can transpose, and then we can see this is like the label, becoming the label. So we can see this as our target, and then this one is the actual feature. Okay, so this is the target. Now, having the target, then we can group, we can do unsupervised learning by distance, for example. Okay, this is unsupervised learning. Okay, and then we can see the cluster, how the cluster looks like. Okay, now we can see the cluster like this. Of course, you can do it like this, or manually, or zoom out, zoom in, or, oh sorry, we can set max depth into 11. See, okay, so basically, okay, uh, we have this. The cluster is not really cluster. So basically, this is one cluster, but if we select this one, it will select all of them. If we select the rest, so this is not a good cluster. Let me see if I can change the algorithm a little bit. Oh, it's nope. Okay, change the algorithm. Still difficult. Change algorithm. Still. So our cluster is like this. So basically, this is how we cluster the our goods when we sell. So this is one cluster: frame, pencil, hooks, bowl, cake stand, and this is one cluster. This is the key ring, is the goods next to this cluster. Notebook next to key ring, candle, notebooks, keyring, and so on. And that's how we cluster things. Okay. So this is, but we shift. We have to transpose the data set first. Okay. Then we. Oh, okay. How about this one? Oops. Then error. Okay. Okay. So you have to play around with this algorithm, then you can see a lot of things. Okay. So this is one. Let me see if you have any questions. Transcribing this call with my tacit. Oh, okay. Do we have pin for attendance for today class? I don't know how to access the pin. So every time is Professor Wiranto who send you guys pins. I don't know how to access the pin, to be honest. I don't know. Because I am not the actual. So I don't know. To be honest, I don't know the pin. Yeah, if there is Professor Wiranto in this class, then he normally knows how to generate the pin. Okay. Uh, okay. Any other questions? Okay. Let me see if other things that is of interest. Okay. Uh, Let me see if I'm a bit reluctant to analyze text. I will show you the text that I have. I did send you my journal paper analyzing the Satu Indonesia Award. It's basically analyzing text. So let me see the actual text. I think in this one. I think in this one. Okay. Okay. See this? Edit. Open. Okay. Uh, okay. So this is the Satu Indonesia Award data. Basically, so we can I zoom in? Oops. 200. Okay, it's much easier to read. So we have numbers, we have year, we have code, we have name of the actual person, and all of this data is text basically, and we have mark. Okay, so this data, this number is actually the average number of all the jury. Okay, so basically this is like how we mark an SI exam. If you have exam with, and then you have to tell a story or you have to write something, then the teacher will mark your essay here. So this is the mark from all the jury. Okay, and then I feed the data. Orange will read the data and use this as feature. So all of this becoming a feature. So uh, the feature is not numbers. The feature is actually text. Okay, so orange will read all the text, and this becoming the target. This is the target. Okay, so this feature, this one is target. Having the model, and then if there is new text coming, the text will be compared to the model, and then it will ask for it will predict for the mark. Okay, so that's basically how it works. So very similar to this. It wrong. Oh, wrong. So basically, I just draw something. So basically, I can so it read files, and then I will create. For example, I normally use for this one, I use random forest, okay, and then I do the prediction. Where is the prediction? Prediction. The prediction uh, is the data, the read data like this. The problem is we need to convert the text into axis, into vector basically. So to convert the text into vector, I normally use this one. Okay, so I send the data into text into vector, and then this becoming, they call it text mining. The output is corpus data, and then I will calculate the actual vector. When calculating the actual vector, I normally use this one. This actually calculating the actual factor. Back of words is actually calculating the actual factor. So the output of back of words is basically how, this particular word, how many words, how many of it. Say, so it will calculate this word. Kendala, how many yang, how many dihadapi, how many this. This will be done by back of words. So having this back of word, and then we can fit into random forest, and then reverse to prediction. The same thing here. We have to replicate this one, duplicate, paste here. Okay. So we need to do these things like this, and then fit here. Then we can predict the. Oh, sorry. I think we need to specify the target first before we fit into random forest. Then after that we can do the prediction. Okay. So we do this kind of algorithm to for text mining, text analysis like this. This kind of thing is interesting because, for example, in media, we can change this into how much money we can get from certain information. In media, normally they write a lot of articles. For one articles, how much ads we can get, and then we can predict a certain article, how much ads we can get from certain articles. It can be articles, it can be the not the name, the title of the articles. So we can do that kind of prediction. Oh, okay, 2015. Okay, any more question? A few weeks back, my brother got an absent on attendance list from our even though we were attending the class. My brother's in. Okay, the problem is I don't know how to set up the pin. Send me email, okay, and I will tell Professor Wiranto about this because I don't know how to set up the pin and so on. Okay, send me email, and then I will tell to Professor Wiranto about this because he's much better on these things. Interesting. So in President University, attendance is important, eh? In my university, in my class at least, I normally don't care about him. I personally don't care about attendance. Okay, thank you very much. Oh yeah, last things. So this is the class. Please make sure you do the exam here. If you do the exam in the other websites, fine, just tell me. And then I just want to show the report here. Several people have not done the exam. Okay, make sure you do the exam. You can do the exam multiple times, and it will collect. It will record the highest score only. Okay. I really hope you can pass more than 80. Okay. So those who still less than 80, please redo the exam. So hopefully your mark will be more than 80. Okay. Let me see if see this. Okay. If there is no mark in your name, I'm not doing the exam because I can set the mark myself. That's cheating. Okay, if you have not done the exam, if you less than 80 or 90, feel free to do the exam. Okay, I hope all of you will pass 90. Then I am happy. Okay, thank you very much. See you next week then. Thank you. Okay, bye bye. Okay, okay.